Hey, welcome back. Good to see you all again, and Happy New Year. First video of the year. So yes, Happy New Year. Hope your holiday season went well. Hope you didn't overindulge and get carried away. Everything was good. So yes, today on the bench I have a Akai CS-M01 cassette deck here. Now I think this is part of a package deal where they have the amplifier, the cassette deck, or maybe a receiver cassette deck, and a turntable. It's sold as a package. I think that's what the owner said. But he brought it in to me for service. Wasn't specific on if there was anything wrong with it, but he gave me a to-do list here. Clean the pots and switches, okay. Refurbish electronics as needed, so I'll go through and check, see if it needs anything. Relatively new cassette decks like this, electronics are pretty robust and they don't fail. Not like stuff from the mid-70s or early 70s. Still has a little life left in it. So install new belts. Well, we'll check and see if the belts are shot, and we can put new ones on if we have to. Retrofit LED to existing bulbs. I don't know, does this have LEDs in it or bulbs? So it's got lamps. Lamps are all working. Making an awful noise. The motor's making an awful noise. Loud too. Okay, we'll get to that. Line the heads and calibrate the meters. Okay, so it's basic, just service. Let's see if this thing runs. The motor doesn't sound too great. Probably just needs lubrication. It sounds dry. Okay. Play. It's playing fine. And we have audio on both channels. The meters are going. Looks like it's running pretty good. But we'll open it up and have a look inside anyway. This is not a high-end deck. It's ferrochrome, normal, and chromium tapes, and we have Dolby switch here on and off. I think that's Dolby B. Not sure. Dolby noise reduction, doesn't say what kind it is. It has a timer switch, which is kind of a nice feature if you're recording from a radio. You'll say you want to record a radio program at a certain time. Single head, not auto reverse. It's pretty mechanical buttons, so it's pretty vanilla, but we'll see how it works here. Let's have a look. Here's a look at the internals. Tape drive mechanism up here in the corner. This is something I don't like, is when they have this exposed 120 volts mains wiring. That really bugs me. There's no reason for this. This has this transformer that's potted in some kind of epoxy or something. That's interesting. I've never seen that. But I guess for whatever reason it's what they wanted. Electronics board, everything looks good. Mostly Sanyo caps. There's some Nippon Chemcons. And there is some Nichicons here, but they're all good brands, except for maybe the Sanyos. But we'll check a few of these, and we'll see if they... I don't expect to find anything in here though. The belt itself is like pretty tired. It's lost its spring. It really doesn't have any pushback. And then we'll do a motor service because this motor is quite noisy. And as far as the meters go, the lamps are built into the meters, so I'm not a big fan of ripping those lamps out and putting LEDs in their place. If it's working fine, just leave it alone, I think. That's my thought anyway. I'd rather leave that alone. It has a nice original look to it, both working. Everything's fine, so I don't think LEDs are the choice here. So leave that. Unless the owner really wants it, I'll leave that alone. Everything else looks good. There's a large mechanical thing here from here. Mechanical linkage, levers, whatever, and then it slides under here, and then you have our record play mode switch here, and that's activated through this ridiculous lever system, mechanically anyway. I think they could have done something easier than that. I've seen them where they put it just like a single cable, and they have it, and you can adjust the cable for tension, and it pulls on that just as easily. But whatever. Okay. All right. It's fairly basic, not much to do. Some switch cleaning, some pot cleaning. Let's tack the motor first. It's very easy to switch belts on this. You just pull out 3 screws and this back plate comes off, and then you have full access to the belts. There's another belt here for, I'm assuming this is fast forward rewind. No, that's a tape counter belt. No, it's some kind of a, it runs a worm gear. So it might be for the system. And this belt here is tape counter. That one is really... But it was working when I tried it a few minutes ago, so... Okay, let's start on this. First thing I want to do is insulate these connections for the mains wiring. And just heat this stuff up. So I know if I don't do this now, I'll probably end up getting zapped on this later. 120 volts isn't a big deal for me. I've had it many times. I know people in the UK and that they have 240 volts. That would be a little more scary, I think. 120 volts. I'm not going to say it's safe, but it's not as bad. You certainly know when you get hit by it, but it doesn't throw you across the room. Just going to trim off this excess. Get rid of some of that danger here. Okay, that's better. So to remove the motor, I'm pretty much going to have to, well, I have to remove the front faceplate, which is fairly simple. You six screws, 3 on top, 3 on the bottom, pull the knob off, and this comes right off, and it gives you full access to the mechanicals. And I can reach the motor screws from here, so I don't need to do any further disassembly, which is nice. And I can do all my cleaning and relubricating here. This lamp was still working, so I'm going to leave that one alone. And everything else, it's just a matter of lubrication. So it's pretty easy. I think for starters, we'll just remove the motor. 3 screws. Oops. We'll fish that out later. Take the belt off and our motor's out. We can disconnect this from the wires, and then I'll take it apart and we'll get that mung on there. Alright, so here's a look at, see how dirty the pulley is. Okay, yep. Turn the power on. Yeah, I think it just needs lube. So, in order to remove this motor and disassemble it, I have to pull this pulley off. It's aluminum pulley. I don't have a puller. I need to get myself a puller because I run into this all the time. When you're servicing motors, sometimes you have to remove the pulley, and they're pressed on. And usually, if they're pressed on, sometimes they're held in place with some kind of adhesive or Loctite or something. Yeah, look at that muck on the surface there. That contributes to wow and flutter. Here's your date code, 1980. So it's a late 70s deck, early 80s. Okay, I think it just needs lubrication. Here's a look at the tape drive mechanism. It's dirty, a little bit dirty. This head though has quite a groove cut in it, and I can feel it with my fingernail. So I don't know if there's any hope for that. We'll see how it sounds. The race head is usually not a problem. Pinch roller looks okay, it just needs cleaning. So everything looks alright here. It doesn't look like it's been used too much. Mechanicals are all working. Alright, not the best motor to work on for servicing. These are pretty much a disposable motor. They're staked on the back so the back cover can't come off. But we can remove the cover, you just have to do a little bit of force. And the pulley needs to come off. So let's try the 2 screwdriver method. Now, you just want to go easy on this. You don't want to put a lot of force into this. You want to use 2 screwdrivers, because if you use one and you pry up on one side of that pulley, the shaft is pretty flimsy. It's going to bend over and you'll have a bent shaft, and then the motor's garbage. You want to keep that shaft straight as possible, so equal force on both screwdrivers, and just give it a very, and this is not coming, so I'm not going to force it. What I'm going to do is use some heat. Just going to heat this thing up. Now obviously you can't do this if it's a plastic pulley, but on brass and aluminum this works for loosening the bond between the shaft. We'll just get it good and hot. There we go, that should be good. And it should just lift right off. Look at that. With no force. It's a little sticky. I think it's got some kind of a adhesive on the shaft. To get it before it cools down. Yeah, it's got something on the shaft here, which is okay. And there's a plastic washer. It's an oil sling washer, so that oil can't get up onto the pulley. We have our bearing. Okay, so let's pop off the back. If you get a pair of nips in here, and you just careful this part, because this is Bakelite. It'll break very easily. Let's pull up on that and pull up on this. It's already loose inside, I can hear it. We might have to back off on this a bit. Can't get in there. Okay, let's try this some more. There we go. Okay. Now don't ever pry on this. That's what I'm just going to sneak a screwdriver in here and see if I can maybe get a lift on here somehow. I could probably pull off the lid now. Okay. You don't want to damage the circuit board. That's what my... Okay, we're all in. All right. Now, before I start ripping things apart, this is positive here, so let's mark positive on here. You need it better. Something that's not going to wipe off. Okay, it's positive. can remove the circuit board. Okay. Let's mark this one positive as well. Okay, so how do we get this open? We can oil this bearing from the outside, but this bearing here we can't. We're going to need to remove this plate. So let's bend these crimps out. A little bit more. I wonder if that's enough. And there she goes. Don't be tempted to pull this cap off because you'll rip the brushes. Push the shaft up and then grab the rotor with something, and there we go. And you can see how delicate those brushes are inside there if we can get focus. They're very thin strips of metal, and if you bend them all up, oh, there it goes. Okay, so we can lift this a little bit, and I'll put a drop of oil in there, and then we'll be good to go. Oops, out it came. Okay, I'll have to put that back. Let's use our drop of oil. And then we'll put this back together. Yeah, it's gonna work. I'm gonna need this. There we go. Okay. Fell into place, and my brushes are good. Okay. Hold these two together and cover the bearing with your finger. The magnet's going to want to pull it in, so your fingers to stop it. And then in a controlled manner, just let it go in without separating these two, the armature or the stator, the rotor and the armature. Positive to positive, line that up. Lubricate our outside bearing. Okay, let's bend these. Should be good. Okay. Let's get some DC on this, see how this motor runs. No, we're not going to put 26 volts. Let's see what we need. Probably about 6 volts. 8. Okay. 8 volts. Let's see how it runs. It's nice and silent now. It's running nice now. Okay, I'll let that go for a while. Let's have a look at this. .3 microfarad and 10 microfarad. It's hard to see this. There we go. So what do we have here? That's pretty good. Here. That's pretty good as well. They're both good. Okay, we'll leave that alone. So that's what I'm working with here. I don't know. Anyways, we got enough. So speed adjustment, regulator IC, a couple caps, a couple diodes, a choke, 3 or 4 resistors. Pretty basic circuit. I'm just checking to make sure we don't have any crack solders. I don't think we do. Okay, I'm going to clean this. That looks a lot better. Okay, it can go back. So I got it at 8.6 volts, drawing 180 milliamps. No, sorry, I'm not. I'm drawing 21 milliamps, 180 milliwatts. It's got lots of torque. It's a lot quieter. Put it back together. Positive here. Okay. All right. This one's still up in here. Okay, everything's good. All right, we can put this back together. The tricky part. You should be able to get it. There we go. Let the snap back in. There. It's as good as I bought one. Okay. Reinstall that. Oh, almost forgot our wheel. You see it has something in there, some kind of chemical or something. So I'm going to push this on. Push it onto its final position. Let's give it a little more. There. Just a touch. Oh, you know what? I'm missing something. Ooh, that's hard. I'm missing that little washer. Where'd it go? Okay, let's put the pulley on. Got our spacer washer here. It's just an oil sling. It's not meant to go fully down, otherwise it'll rub. Okay, so we got our, this side was up, it had the groove cut, so let's put this side up. And there should be enough residual chemical there, we can just remelt it and have it flow. So let's do this. Just heat this up one more time. Ouch. Okay. Let that cool, and then I'll give it a tug test and see if it's holding. And then I'll clean all that crap off the pulley. Alright, for the belt to remove this plate, it needs 2 screws, 3 screws. Let me see if I can get this last screw. And this plate should come right off. It's attached with a spring, so just leave it here. And here's our belt. Now, it's kind of, actually it's not bad. It does have some spring to it. It's not all limp, and you can tell a bad belt when you pull on it and it just kind of gives and gives, and it doesn't have any resistance. But this one, you can stretch it and it's got a little bit of resistance to it. So I'm going to give it a good cleaning. Just remove our flywheel. We have another belt on here. Let's pull this belt off. Look at that one as well. It's a heavy flywheel. Okay, so we'll check this belt out, and then we'll clean this. This surface has to be cleaned. This little surface has to be cleaned. It's kind of a unique design. Okay. This belt here, this one's good too. It's got lots of life left in it. And there's a tire back here. I think that's our fast forward rewind tire. We'll check its operation, but we're gonna clean these belts. I have a feeling these belts are still in good shape. Give them a good cleaning. They're dirty, very dirty belts, but they need once we clean them up, they'll be good. It's not too bad. A little bit dirty. Oh, you can't even see what I'm doing. Crazy camera. Okay. Problem with these little cotton things is they spew cotton everywhere. It's not too bad. You just got to dust it off when you're done. That's clean now. You can see Everything's good. This little surface here. It has little micro splines, and then the rubber and crap gets caught up in the groove and fills in the little valleys, and it makes it smooth, and then it loses all its traction. So you got to clean these things off. Here, that's perfect. A lot better. Now let's move on to the belts. Let's get a cloth, paper towel. A good dose of alcohol in there. Oh yeah. Still picking up dirt. Okay, that should be good. And if it, I can still clean this with rubber renew, and that would really make this thing snap back to life. I only like using rubber renew as a last resort, though. Usually alcohol is good enough. Just clean it with alcohol. It removes all the films and dusts that get embedded, and yeah, it's much better now. It's got a chalky feel, though. I think it's. Let's do this one. This one's not as critical. And it's still dirty. Getting a brown stain. Square belts are easy to get, though. This one's good. Okay. Okay, so I go with a very light coating of synthetic grease on this half of the shaft, and I got my belt in place. So let's just put this back in, if I can find the hole. I think it's right here somewhere. And our belt's caught already underneath here. There we go. So let's fish this belt out. And hook it. And then send it home. Very good. Give it the same treatment on this side. Very small amount. Put some inside this bearing. And if I can get, there we go. You know how that spins so nice. Okay, we can secure this now. So I'll screw this back together. Let's see. I think we're done back here. I'm gonna put this back together, put the motor on, put the belt. Oh, I gotta put the belt on before I put the back plate. That's true. I can't forget that. So I'll do all that, and then we'll get this assembled. We'll concentrate on the front. Have a listen to this. It's a lot quieter. Can't even hear it now. Before it was growling away. It still has troubles. I'm gonna shut this thing off. When I started, the belt wants to climb up. But it's silent. The motor's really quiet now. I'm just going through and checking ESR on some of these caps, and everything's looking good. Haven't found anything that's bad. These caps are all holding out really well. What is this one? 4. That's a little high, but that could be because, what value is it? It's a 1 microfarad. So 4 ohm ESR on a 1 microfarad cap is really good. So let's see here. I've been going through and checking them, pretty much all of these. Not getting anything. I can't check these big ones because I can't get under them. I can check them from the back side. They don't show anything. I'm going to remove a couple of these just for the hell of it, and just test them on my other machine and see how they... 9.9. Even these ones around by this big power resistor here, you would think it might get hot, but they all test out okay. 1.7 there. So much stuff in the way. Can't get in there. 3.9. What value is that one? That's another 1 microfarad. Yeah, even these blue ones are holding out. These are low value. That reads 20, but this is a 100 nanofarad. That's why it's so high. And this one's a 330 nanofarad. And that comes out at 8.3. That's really good. Some blue ones back here. If I can get in here. Yeah, same thing. Caps are pretty healthy. I'm not going to get too excited over caps here. So I did take this, let's see here. So I did remove the board and gave it a good look. I can't find any cracked solders on this board. I don't see anything, but I'm going to give this a clean anyway, especially around by these switches here. They have something here. Is that glue or is that rosin? I think that might be rosin. I think they might have hand soldered these switches in place after the board was wave soldered. That's what I think. That's why we got rosin all over these switches. I'll clean all that off. Checked in the power section here. There's no cracks. A couple of transistors. I don't see anything going on. Bridge rectifier here. I don't see anything. So what I'll do is, like I said, I'll pull a couple of these big caps out and check them on my other meter. I'm expecting they'll be fine, but we'll check them anyway. And then I'll give this board a clean, and it can go back in. I hope you can see this. This is the auto stop mechanism. It's in stop mode right now, and the motor's still going. So you can see this worm gear is going here, and this lever's cycling back and forth. So let's put it into play. And you can see it still continues to do the same thing. But watch what happens when I stop the tape, as if I simulate the end of the tape. So I'll stop it. And then it goes to auto shut off. And that works for forward and reverse. I just stalled the machine. It should be shutting itself off, but it's not. Let's try. Going auto reverse. Reverse shuts itself off because this spindle's not turning. Let's try that one more time. Play. Yeah, it's all working. So if your auto stop's not working, this is probably your mechanism that's causing the troubles. There is a belt that drives this worm gear, and if that worm gear is not spinning, it's not going to auto shut off. So I'm pretty much done with this except for adjustments. Everything's been cleaned, switches have been treated, the pot. I had the main board out, checked everything, checked the caps, they were fine. Did the belts, we cleaned the belts, we made the decision we're going to go run with the old belts because they're still running strong. I'll leave everything alone. Adjustments is a matter of setting the tape speed, which is adjustment on the back of this motor. I'll get my speed adjustment tape out and get that all connected. And then a matter of just running it through my azimuth alignment. I can look at the head here, and it's never been adjusted. I can tell just from the lock glue they use to lock up this screw here hasn't been tampered with. So I'm usually in a case like this, I'll check it. If it's still good, I'll leave it alone. If it's really badly out, if the tape sounds horrible, I'll try tweaking it. And if tweaking doesn't help, then the head is worn beyond use. And this one does have some wear on it. I can feel it with my fingernail. But since I cleaned it, I'm not going to touch it now. Demagnetizing, I will demagnetize this, but you don't have to on the single head decks. You typically don't demagnetize the head because when you put it into record mode, that happens automatically. Now, on the 3-head decks, you have to demagnetize the playhead because it never sees that bias frequency that's applied to the head that does the demagnetization. So, what am I going to do? I'm going to go through, check speed. I'll check the alignment, and then if that's it, we're going to wrap this up. Okay, so for the most part, I did the calibration on the speed. It was out by maybe 1.5%, so I tweaked that up. And I adjusted the meters so that they're both equal. I'm feeding it a mono signal, and it's in record mode right now. Everything's working the way it should. Didn't have to touch anything else. Everything else is pretty much bang on. I've checked a few things. Spot checked a few other adjustments and they were good, so I'm not going to touch anything here. For the most part, you don't have to make adjustments on a cassette deck like this unless you got major head wear or something's been obviously changed or replaced, or it's big changes. But everything's working good here. Not much else to say about this. Copyrighted material here. I don't want to turn this down. And let's see here. It does sound good. It sounds much better. I did adjust the head azimuth a little bit, and it brought it back in from where it was a little muffled. Now it's a lot more clearer. Leave that alone. That adjustment's locked in place now, and everything else is done. I just need to wrap it up and send it home to its owner. So I'm going to leave this one here. Talk to you later. Thanks for watching, and hope to see you on the next one. Take care.